what we're going to be doing now. It dawns, dark and dreary and a little bit miserable, but that's okay because it's the perfect time to just bury yourself in a couple of blankets, put on some chill music, open up your laptop, and then do some math. So, where we're at right now, this video is for Algebra 2, Goal 4, and specifically I zoomed in on one particular family of topics in Chapter 4. Two of these topics are basically kind of absurdly simple. One of them is about a medium, and then one of them, which is a DSA question, is legit takes a while to kind of wrap your heads around. So that's where I'm going to be focusing my time and efforts. And again, I'm going to be doing a lot of factoring for some of these. Or wait, before I say that, a couple of these will be factoring, but most of these, again, is going to be the quadratic equation. X equals opposite b plus or minus square root of b squared minus 4ac all over 2a. So keep that in mind as we're going through this. Again, if you're more comfortable with factoring, you can do factoring, but that only takes you so far. And this last one in particular, solving a word problem using a quadratic equation, it's deliberately designed so that it won't be factored, but that's going to be the last topic that we're covering. First things first, solving a quadratic written in factored form. So let me zoom in a little bit so we can actually see the screen grabs that I grabbed. So solving an equation written in factored form, like literally when you realize what you're doing for this, it's kind of absurd because what you're actually doing is you're taking each individual piece. So if we look at this specific equation, we have the 5v and then v plus 1 and then v plus 8. Those are three separate occurrences of the v. They're each written in their own specific either set of parentheses or they're just left by themselves. So what you're doing is you're taking each of those 1, 2, 3 segments and setting them equal to the all-powerful 0. If you haven't noticed it yet in Chapter 4, you will over time. The question that you are constantly asking yourself is it set to 0? Because that's what you're going to be doing in order to solve your quadratics. So, first things first, negative 5v equals 0. And then, ooh, it's purple. V plus 1 equals 0. And then v plus 8 equals 0. And every single one of these are pitifully simple in order to solve. For this one, we're just going to divide by negative 5 on one side, and then we're going to divide by negative 5 on the other. Over here, we are going to subtract 1 on one side, and then subtract 1 on the other. Over here, we subtract 8 on one side, and then we subtract the other. And what are we left with? All of your answers for this particular problem. You're going to be left with v equals 0. You're going to be left with v equals negative 1. And you're left with v equals negative 8. Like, I have other problems here, but I don't think I need to actually give them to you because that really is how simple it is. You set each piece to 0, you do some very basic algebra, and then you solve. The only one I could think of that might cause maybe a challenge if you look sideways and blink really hard is something like this. So I'll go into over here, give myself a little bit more room. Now there's only two z's here, so we have 2z plus 5, not 56, Ms. Dubois, 5, that equals 0, and then equals, stupid keyboard, equals 0, and then you have 2 plus z equals 0. And again, what you're doing is really easy. So you subtract 5 from both sides, so 2x equals negative 5, and then you divide by 2. X equals negative 5 halves. There's your first answer. And then for the next one, we subtract 2 from both sides, so that means z equals negative 2. And there are our two answers, negative 2 and negative 5 halves. So in other words, you can in fact sometimes have fractions as answers for this particular topic, and we're okay with that because the fractions are not deliberately designed to make you hate them. Huzzah! So that's writing in factored form, and there are other types of topics that actually lead into that. Those were earlier topics that I talked about in an earlier video, but I didn't outright name them. Next on the, let me zoom out a little bit here. Next on the to-do list is the other one that is absurdly simple, writing a quadratic equation given the roots and the lead coefficient. The wording for this one is always a little bit awkward for some students. They don't quite understand what it is they're asking, but now that we've just done this topic, we have a much better idea of what's actually happening. Give me a second to drink my water. All right, so what are we told? We're told the roots are, and this is too big, so let me make that a little bit smaller. We're told the roots, computer, are 1 and 2, and we are told the lead coefficient is 1. So what does this tell us? We know that our answer is going to be 1 times x something and then x something. Hey, that looks familiar. I wonder where that comes from. But if we think about what we're actually doing, if I can get these both in one view, which I don't think I can, not make this legible. All right, what we're going to be doing is, because they're telling us if the roots are 1 and 2, what they're ultimately saying is that x equals 1 and 2. So if we set that up, if we have x equals 1, well, is it set to 0? No, it's not. So we just go through the effort and saying minus 1, therefore x minus 1 equals 0. So that then, there it is, your x minus 1. That's what's going to end up going in here. So minus 1. And then if we do it again for the 2, x equals 2, minus 2, minus 2, x equals minus 2. And if you're really good at pattern recognition, that's a positive 1, that's a positive 2. That's a negative 1, that's a negative 2. Huh, funny that. So now if I scroll down a little bit and look at these ones, we have 1 and negative 2. How many people want to take an educated guess on what the answer is going to be? I'll start setting this up and you can think about it. So what are we told? We are told our lead coefficient is 2, and then our roots are 1 and negative 2. So what does that actually mean? That means x equals 1 and negative 2. So if I go through the effort, the lead coefficient always goes in front. So 2 parentheses x something and then x something equals 0. That's what we're looking for. So what do we have? We have if x equals 1, well, we already did that up here. So we know that the first thing we're going to have is minus 1 because we're going to set to 0. So subtract 1 here and subtract 1 here. X minus 1 equals 0. Therefore, that's what goes here. But what if x equals, negative 2? Well, we're going to add 2 here and add 2 here. So what does that become? That becomes x plus 2 equals 0. And if you guys guessed correctly that you flip the signs when you are doing this particular topic, you're going to get a virtual cookie since I can't actually hand you a cookie because germs. So one more. And this time I'm not even going to do the setup. I'm just going to be able to do it with just by looking. Our lead coefficient is 4. That's nice. Our first root is 6, so we're going to flip the sign. Our second root is negative 4 equals 0. And I didn't even need to think about it. Okay? So these two topics, the given the roots and leading coefficient and then written in factored form, they're similar to each other. One you're writing it, one you're solving it, but it's so absurdly simple that you almost don't need to do a mini lesson on it, right? Then we have our middle tier, which is solving, where is it? Solving a quadratic equation needing simplifying. That one is the one that takes a little bit more nuance because, if I can zoom in, that's the kind of unholy mess that they give you. And so now we have to go through the effort of actually, simplifying, like it says in the topic. I want to give myself as much room as possible, and I'm still probably not going to have enough room. This isn't a lengthy topic per se, so much as there is a lot of steps. The first of which is that x plus 3 quantity squared, I'm going to have to FOIL out. I'm going to give you guys a couple minutes to see if you remember how to FOIL. All right, so take a minute and think about it on your own. All right, if you're going to FOIL, what that means is you're doing x plus 3 parentheses x plus 3, which is going to be, first is x squared plus 3x, which is our outer, plus 3x, which is our inner, plus 3 times 3 is 9. And then those two terms, my 3x and my 3x, simplify to 6x. All right, so now we're ready for doing our actual setup. What do we have? We have 2x squared plus 14x plus 24 equals x squared plus 6x plus 9. At a glance, that looks a little bit scary, but then you're going to ask yourself the question you ask yourself for quite a few of these topics. Is it set to 0? And the very obvious answer is, oh, shiznits no. So that's the first thing you need to do. So I'm going to take one of my x squareds, and then I'm going to move them. So minus x squared minus x squared. Then, oh, this is going to get ugly for the tabs. I'm going to minus 4. What am I moving? The 6x, gotta be careful what side I'm doing. So that means over here, I'm also going to minus 6x. And then what's the other thing that I'm doing? I am subtracting the 9. Get that lined up. And then get that lined up. And over here, that means I'm going to be subtracting the 9. So what I have done, let me get to the highlighter level. Make that bigger. No, smaller. What I've done is x squared is gone. 6x is gone. 9 number is gone. And so now, to my advantage, I now have a new equation that is, in fact, set to 0. What am I left with? 2x squared minus x squared is just 1x squared, okay? What is 14, what am I looking at? 14 minus 6, that's going to be plus 8x, okay? And then what is 24 minus 9? That is 15 equals 0. And again, Ms. Dubois, the magic math, human calculator person, kind of already knows what my roots are going to be. That's going to be x plus 3 and then x plus 5. And again, if you're not comfortable with that yet, because the earlier tutorial I gave you the other day, you might still be working through those topics, you just quickly set up a table for outside and inside. And what are our factors of 15? We have 1 and 15. We have 3 and 5. And which one adds up to 8? The 3 and the 5. That should be familiar from earlier this, actually I think I put the video up yesterday. So that's going to be your setup. And again, is it set to 0? Yes. Does that mean we can solve it? Yes. So that's what we're going to do. So we're going to have our x plus 3 equals 0, and then our x, clearly I gave myself space for this. Then we have x plus 5 equals 0, and then we're just going to solve them respectively. And what are we left with? We have x equals negative 3 and negative 5. There's our answer. So you can kind of see there's a lot to sort of like pick apart here, but none of the work is actually outright hard, because all of this you have been doing in the earlier topics. So you have been building up to this for hopefully several hours now of work into the software. But we'll do a couple more because I know this is mid-tier. I gave you a lot of examples because Ms. Dubois. So next one. I'm going to cut some corners here because I've done this enough times that I can now start to do this in my head. So x plus 2 quantity squared, that is x squared plus 4x plus 4. And again, I have done this over and over. This is the walkthrough. It is x plus 2 times x plus 2. Square it. So first x times x is x squared. 2 times x is 2x. 2 times x is 2x. 2 times 2 is 4. That's where I'm pulling these numbers from. And then what do we have? We have 2x squared plus 10x plus 9. All right, let's do some subtracting. So minus x squared, and then minus 4x, and then minus 4. And then we're going to be minusing x squared minus 4x minus 4. Those didn't line up perfectly. So there we go. All right. No! All right. So when we add that out, all of the left side of the equation cancels. X minus x squared cancels. 4 minus 4 cancels. 4 minus 4 cancels. You're left with your precious 0. 2x squared minus x squared is just x squared. 10 minus 4 is 6x. And then 9 minus 4 is 5. Not that I can type. And again, my brain is hardwired so that I can do a lot of this factoring in my head. That is x plus 1 and then x plus 5. Again, make your OI table if you don't know it off the top of your head, but 5 only breaks down one way, and that actually helps in your predicament. It makes it easier for you. So our x's are going to be, we flip the sign because it's -1, and then -5 is going to be -1 and -5. So that's two of them. One more. Let's see here. Which one looks better? That's 14, and then the 21. That's going to be 9, and then that's going to be 16. I think I like this one better. All right, that's zoomed in too much. So text box, new thing. Delete. Let me take a sip from my water bottle. All right, so 2u squared minus 9u minus 14 equals u squared plus, or nope, minus, Ms. Dubois, minus 8u. And again, catch your mistakes. Be very careful of signs. A lot of my kids who start struggling around this point, it's because they're a little weak on their signs. So be very careful. Even the trained math teacher can make mistakes. Do not be ashamed of it. Just persevere. And then it'll be plus 16. And now I got to move this over and set it equal to 0. So minus u squared. I almost wrote x squared. And then what am I moving? I am adding 8u, because you're always doing the opposite of what you're seeing, and then I am subtracting 16. That looks really kind of interesting. I'll see how that works. So then it's going to be minus u squared plus 8u, Ms. Dubois, pay attention, and then it'll be minus 16. So what do we end up getting when we have all of this done and set equal to 0? 2u minus u squared is just simply u squared, okay? -9 and 8 is minus 1u. Is this u or y? This is u. And then -14 and -16 is -20, -30. Ah, I already know it. Okay. Equals 0. And again, Ms. Dubois is going to show off that is u minus 6 and then u plus 5. And again, the skills for this was done in an earlier video. I set up I set the table up in my head, but I knew what the factors were already because my answer was -1. And again, just go through, finish the solving. Why? Oh my Lord. What is it with me and u and y's today? Okay, so you now know that u equals, flip the sign, so it's going to be +6 and -5. That was really cool. All right, so that's 3 out of the 4 topics. Now I want to talk, this is the topic I'm going to be spending the most time on, specifically because it's a DSA question. And it's not, again, it's not hard. It's actually using a lot of the skills that you're doing in this topic, but it's just long enough where kids start to kind of lose their minds after a while. So first things first, let's actually read the problem. Can I get this all on one screen? No. All right, the area, voice crack, the area of a rectangle is 45 feet squared, and the length of the rectangle is 1 foot more than double the width. Find the dimensions of the rectangle. The horror, the horror. How in the name of shiznits are we supposed to do that if we don't even know what it actually looks like? Well, about that. Where's my highlighter layer? Hey, look, there's a rectangle. All right, so now let's do some figuring. We do have a width that we don't know anything about, and then we do have a length that is very specific. It is 1 more than double the width. Hey, dimensions. We can work with dimensions. And what are we told? We're told the area. Okay, we can work with that. So area is length times width, right? So the area is 45, so that's going to equal our W times our 1 plus 2W. Huh, okay. So without much in the way of work, we were able to kind of come up with an equation. That's good. Sorry, the Z is I'm trying to zoom in. So then what do we actually do with this? Well, we have distribution, right? So W times 1 is just 1W, and then 2W times W is 2W squared. And now that infamous question I'm going to be asking on this in the next video, is it set to 0? Well, No, it's not. So we're actually going to go through the effort of subtracting 45, subtracting 45. So 0 equals negative 45 plus 1w plus 2w squared. Now, very, very important because it says in the title, quadratic equation, x equals opposite b plus or minus square root of b squared minus 4ac all over 2a. You can tell I've been talking for an hour. So what we're actually going to do here is be careful of our labeling of our A, B, and C. If you recall, I'll scroll up, your A is with your x squared, your B is with your x, and your C is the number by itself. So if those of you who have been used to labeling your A, B, and C based on the order, do not let the order fool you. Let your x's instead guide the way. So if we're looking down here, text box, x equals opposite b. So opposite b is going to be negative 1 plus or minus the square root, this is terrible typing it, square root of b squared. So 1 squared minus 4 times a, which is 2, times c, which is negative 45. And then all of that is over 2 times a, which is 2. And look at the unholy beast that is in text format. I wish I could use the brush tool in Photoshop and actually record what I'm doing. It would be so much easier. So what are we left with? We have opposite b plus or minus the square root. Let's simplify the stuff in the square root. What is 1 squared? 1. What is a negative times a negative? A positive. What is 4 times 2 times 45? Okay, so 45 doubled is 90, and then 90 times 4 is 360. Okay, and then all of that is over 2 times 2, which is 4. So a little bit of work. It's starting to look a little bit nicer to us. Okay, we can work with this so far, nothing hard. And then it's going to be negative 1 plus or minus the square root of 1 and 360 is 361. All of that over 4. And by now, if you've been paying attention, alarm bells should be going off in your head. Wee-oo, wee-oo, wee-oo. Because 361, why gosh, that number sounds familiar. Where have I seen it before? What does it mean? What possibly could 361 actually have any significance whatsoever with what we're doing? I wonder, I don't wonder. 361 is the root or the square of 19. So let's go back over here. Oh, geez. No! What did I do? All right. 361, I know exactly what I did. All right, now we are all set. Let me give myself a little bit more space here. And you can kind of tell just how many lines this is taking and how this is nothing hard, nothing at all hard, but the workload itself is starting to get a little intense. So what do we have? We have negative 1 plus or minus the square root of 361. And what is that again? Oh yeah, 19. And then all of that over 4. Okay, so we ran out of space. We're going to move over a little bit, let ourselves chill. What do we have? We have negative 1 plus 19. Negative 1 plus 19 is 18. 18 divided by 4 is 4.5. And then negative 1 minus 19 is negative 20. Negative 20 divided by 4 is negative 5. Okay, so the computer spat out the human calculator or the work or however you want to justify it, it has spit out two different answers. You have 4.5 and negative 5. The question you're asking yourself, and there's another topic later that you're going to be asking the same question, this is a real world problem. Can I have a negative 5 as a dimension? Yeah, no. Okay, so that means our width is 4.5. Huzzah! We have figured out what our width is, okay? What are we looking for? Find the dimensions of the rectangle. So that's the width. Now we just got to find the length. What is the length? The length is, well, what does it say? It says so right here. It's 2 times the 4.5 plus 1. What is 2 times 4.5? That's 9 plus 1 is 10. There are our dimensions. And that is the level of work you're going to be doing for this particular topic. And I say again, this is a DSA topic. So this is one that you can't really ignore. You kind of have to put it under your belt. So a couple more examples of this because this is pretty involved and I want to make sure you guys are comfortable with this. So let me scroll down to the highlighter section for a second and get my rectangle set up. So we have a rectangle here. And oops, bad stop, not what I meant. Marquee there, that's the one I want. So we're going to set up a rectangle here and fill it in, and then we are going to set up a rectangle here and fill it in, and now we're ready for our text tools. Okay, so what are we told here? Is that everything I need? Length twice width 63. Yeah, that's everything I need because I know they're asking to find the dimensions. All right, sip of water. I'm going to streamline this a little bit because up here I had to kind of explain everything in rapid detail, which meant I had to remind you the area of the formula, quadratic formula, etc. This one I'm going to do a little bit faster. So what does the area? Area is 63 equals the width times what is the width? Let's actually figure that out for a second because I'm not going to remember that off the top of my head. It is 5 more than twice the width. All right, that's what we're looking for. So what goes in here is going to be 5 plus 2w. So 63 equals 5w plus 2w squared. Subtract from both sides, so 0 equals negative 63 plus 5w plus 2w squared. All right. So square root formula, x equals, or in this case, w equals, because that's what we're looking for since that's the variable. Opposite b, so it's going to be negative 5 plus or minus the square root of b squared. So 5 squared minus 4 times a, which is 2, times c, which is negative 63. I might actually need my calculator for that. We'll find out. Let's see here. All over 2 times 2. All right, so w equals negative 5 plus or minus square root of. So what's 5 squared? That's 25. Double negative is a positive. All right, so 63 doubled is 126. What is 126 times 4? Pause for a second. I actually do need the calculator for that. And I'm not going to do that in front of kids. Okay, I lied. I am going to do it in front of kids. If Ms. Dubois needs the calculator, then you know something is up. All right, so what are we at? We are at 63 doubled was 124, so 4 times 124 is going to be 496. That's a little big, so I know I'm not going to be able to do the square root for that in my head. All right, so that's going to be over here in 420. Oh my God, what was it? I just had it. Wait, what? Okay, this is where we all roll our eyes and realize that Ms. Dubois is just as human as everyone else. So it is going to be escape, clear, clear. So it's 4 times 2 equals times 63 equals 504. How the heck did I get 4 something? All right, 504. 504, all of that over 4. All right, so W equals negative 5 plus or minus the square root of, what is 25 plus 504? That's going to be 529. 529. That is a perfect square. Oh, but I don't know what that is off the top of my head. All right, so let's see if the calculator has a square root function. It does. All right, so then what is the square root of 529? 529 root 23. I knew it. I knew it. Okay, so W equals negative 5 plus or minus, what was it? 23. Eep! plus or minus 23 all over 4. Okay, that was way harder than it needed to be, Ms. Dubois. Pay more attention and actually be prepared next time. The problem with doing these things cold is that you sometimes realize you need things that you didn't set up for prior. Oh, well. So what do we have? We have negative 5 minus 23 is going to be a negative number. I'm not even going to entertain that as an option. So what's negative 5 plus 23? 18. Okay, so 18 divided by 4 is 4.5. Okay, and then the length is going to be 4.5, not 4 divided by 5, Ms. Dubois. So it is going to be 2 times 4.5 plus 5, which is 9 plus 5, which is 14. And there are our answers. All right, given that that problem was a little bit messy, I'll do one more with you guys, and then I'll set you off into the wilds. So, trying to give myself more space this time. 45 is our area, and it is the length times the width. Okay, so W times 1 more than double the width. You can see I'm shorthanding it even more. At this point, I've gotten good enough that I don't even need to draw the rectangle. And again, trained professional math teacher, human calculator, I can do this kind of stuff. The reason why I was drawing the calculator for all of these is to make you guys comfortable with how you find the dimensions. And if you still need to do it, 3 or 4 times into this topic, I am not going to blame you. I do not care. However you get there is how you get there. So, set that equal. So 0 equals negative 45 plus W plus 2W squared. And now we're ready for the quadratic formula. So W equals opposite B. So negative 1, name in parentheses, negative 1, let's see here, plus or minus the square root of b squared, so 1 squared minus 4 times a, which is 2, times c, which is negative 45. 4ac, and then all of that is over 2 times 2. All right, so w equals, what did we have? We have negative 1 plus or minus the square root of, what is 1 squared? 1. Okay, 2 times 45 is 90. 90 times, wait, that sounds familiar. 1 plus 2w, 45. 1 plus 2w, 45. Facepalm. Wow, okay. I'm going to head desk in a second. I'm just going to bang my head. Yep, so the problems ended up being doubled. But do you understand the process? I'll finish going through the process. It's worth it just to get you guys comfortable with it. So that's going to be plus 360. Well, at least I know what the answer is going to be coming in. And 4, and then w equals negative 1 plus or minus the square root of 361. Not that I can type 361 all over 4, which means w equals negative 1 plus or minus 19 over 4. When we do that out, our w equals going to be 18 over 4, which is going to be 4.5. And then what's our length? Our length is going to be 2 times 4.5, which is 9, plus 1 is 10. Exactly the same as we got before because Baka-sensei didn't read her problems. All right, that's everything for this particular session. What did we learn? We learned, zoom out, these 4 topics. 2 of them, again, were silly to the point of being almost absurd. You can do them without really thinking about it. Writing a quadratic, or solving, needing, simplifying, that one was a little bit more intense, but it's always within our capacity. We know what we're doing. And then the honest to God, let's challenge mode for a second because this is going to be on the DSA. There you go. Stay safe, stay healthy, and I will see you in the next one.